Hi friends, good morning to everyone. Welcome to my channel, Belagali's class. My friends, we are doing 2-mark questions on integration. 2-mark questions on integration. My friends, you might have seen it, everything I have done in detail. Integration by parts rule, some examples are considered 2-mark questions only. By taking definite integrals, I have done 1 mark as well as 2 mark questions in definite integral. They may ask very simple examples under 1 mark. The last example you might have observed it, that is integral a to b dx. Integral a to b dx. There is no wonder, such very simple examples sometimes they ask it. At that time the students will search for what? Integrand, but the integrand is there 1. What is the integral of 1? X. Lower limit, upper limit. So the answer is b minus a. Just it is a very fit under 1 mark questions. Like that, my friends, they ask even on definite integrals 1 mark questions, 2 mark questions. Everything, my friends, I have done. Some 2-3 examples or some examples if I have done more, those examples are not useless. They are useful. They will be qualified for what? Next means what, my friends? 3 mark questions. 3 mark questions. Yes, my friends, while doing, by making use of one very well-known formula, that is integral e to the power x into fx plus f dash x. What is this bracket? There is a relation between these two, man. If it is a function, the side must be its derivative. Function plus derivative of that function with e to the power x. If it is so in this form, then what is the integral of this? It is e to the power x into fx. It is e to the power x into fx. Making use of this formula, I have done nearly half dozen. E to the power x into sin x plus cos x, e to the power x into sin x minus cos x, like that e to the power x into tan inverse x plus 1 upon 1 plus x square, e to the power x into 1 by x minus 1 by x square. I have done, my friends, around half dozen examples which are good examples under even 1 mark also, sin x plus cos x. All those examples are important under 1 mark. Then 2 mark questions also I have done. While doing, there are some examples, they never take a decision whether it comes under 2 mark or not. In such cases, the examiners will forcibly put such examples under 2 mark only. Like that, forcibly putting 2 mark questions, I have selected another 3 examples. These examples are there in your textbook, my friends. Textbook. This is another good example. Even it is appeared in CT also, my friends. Evaluate the following 2 mark questions. We are doing, my friends, integration. Remember, integration. Yes. E to the power x into 1 plus sin x upon 1 plus cos x. In this case, we have to make use trigonometric identities, formulae. Sin x, half angle formula. You know the formula for sin 2a. What is the formula for sin 2a? 2 sin a cos a. Formula for sin 2a. Sin 2a. Sin 2a is 2 sin a cos a. 2 sin a cos a. 2a becomes a. Instead of a, if it is x, my friend, it becomes what? Half of that. Therefore, making use of this multiple angle formula, sin 2a, this becomes half angle because here it comes x by 2. Sin x. 2 sin half of the angle, x by 2 into cos x by 2. 2a becomes a, x becomes x by 2. Upon 1 plus cos x. 1 plus cos x is 2 cos square x by 2. Simplify 1 divided by 2 cos square plus 2 sin cos upon 2 cos square. What is this? 1 by 2 into this is 1 by 2. 1 by cos square is sec square plus 2 get cancels. 1 cos cancels, my friends, numerator, denominator. You are left with sin x by 2 upon cos x by 2. What is sin upon cos? Is tan x by 2. You know the relation now. Derivative of tan is x square. So, Your tan is in the first place function f, tan x by 2. What is this? Plus. And derivative of tan is sec square x by 2. What about the angle? Other than x into coefficient. What is the coefficient of x by 2 is 1 by 2. So, if it is f, this is nothing but f dash it is here. Sec square x by 2 into 1 by 2. F plus f dash. Then by this formula, e to the power x into tan x by 2 plus c. E to the power x into tan x by 2 plus c, my friends. I will explain here once again. This is your example. Half angle formula. Use trigonometric formula. 2 sin x by 2 into cos x by 2. 1 plus cos x, 2 cos square. If it is minus, 2 sin square. That's all. At that time, sin cancels. You get in terms of cot and cosec square. Cot and cosec square. 2 cos square x by 2. Simplify. 1 upon this plus second term divided by 2 cos square. Now it is 1 by 2 into 1 by cos square is x square plus 2 cancels and 1 cos cancels. Sin by cos is tan x by 2. Tan x by 2. That's my friend. If this is your f, it is definitely f dash. So it is e to the power x into f plus f dash is what? E to the power x into f, my friend. F. This is another example. These are slightly lengthy, 1 or 2 steps, my friends. Because of that reason only, the examiners sometimes may hesitate in giving under 2 mark question. 2 mark question. Second integral x minus 3 into e to the power x upon x minus 1 whole square. You wanted that outside e to the power x. Write this. E to the power x outside. What is it? It is x minus 3 upon x minus 1 the whole cube. You want a denominator x minus 1. So, it is x minus 1 minus 2. Minus 1 minus 2 is minus 3. This minus 3 split as what? Minus 1 minus 2 upon x minus 1 the whole cube. Like previous. First term divided by denominator plus minus 2 divided by a denominator. Yes. X minus 1 cancels, you are left with 1 upon x minus 1 the whole square plus minus 2 upon x minus 1 the whole cube. If this is your f, it is f dash. Why tell? You know the derivative of 1 upon x to the power n. Derivative of 1 upon x to the power n is minus n minus the power upon x to the power n plus 1. And instead of x, if it is fx, minus n upon fx to the power n plus 1 into f dash, derivative. It is not x here, it is x minus 1. Then if it is your f, what is your f dash? Minus n minus 2 upon x minus 1, the power is what? 1 more. If it is n plus 1, if it is 2 plus 1 is 3 into 1. Why? Derivative of x is 1, that is why I have not written here. Then this is the derivative of what? 1 upon x minus 1 the whole square. Again e to the power x, f plus f dash. Formula e to the power x into f plus c. So it is e to the power x upon x minus 1 the whole square plus c. Is the second example, my friends. Second example. This is another example, my friends. Anyway, I have not taken any risk leaving any examples. If it is not fit under 2, you may fit under 3 mark questions. Yes. E to the power x into x square plus 1 upon x plus 1 the whole square. It is there. We have done it is for the main exam only. It is there in my videos. It is there already. I have done so many examples based on this. If you wanted to know more examples, we can refer my videos done for what? Main exam, your board exam. I have done in detail everything. Even twisted questions I have done. Twisted. Just refer them. Yes, my friends, this e to the power x into x square plus 1 upon x plus 1 the whole square. Yes, you wanted plus 1. X plus 1 you wanted. To get x plus 1, you must write this plus 1 as what? X square minus 1 plus 2. Minus 1 plus 2 is what? Plus 1. Why it is x square minus 1? Because you know the factors of x square minus 1 as what? x minus 1 and x plus 1. If I write the factors, this x plus 1 cancels with one factor in the denominator. One factor in the denominator. My friends, I hope clear that plus 1 can be written as minus 1 plus 1. Factors of this upon x plus 1 the whole square. X plus 1 cancels. X minus 1 upon x plus 1 plus 2 upon x plus 1 the whole square. If it is f, it is f dash. What is the smell? U by v. My friend, u by v. Now what is the formula for u by v? V into derivative of u, numerator, minus numerator into derivative of denominator upon square of the denominator. What is this? Square of the denominator. When it is square of the denominator, this term is nothing but derivative of x minus 1 upon x plus 1. If it is f dash. Then what is the formula? E to the power x into f. F is x minus 1 upon x plus 1 plus c. If you wanted, just we can see if it is f. If it is fx. Fx is x minus 1 upon x plus 1. Your f dash x. F dash x is what? V into denominator into derivative of numerator x is 1 minus numerator into square of the denominator x plus 1 the whole square. Simplify. Minus x minus of minus plus 1 denominator is square of x plus 1. What cancels, my friend? Plus cancels with minus. Plus cancels with minus. You are left in the numerator. 1 plus 1 is 2 upon denominator is what? X plus 1 whole square. X plus 1 whole square. Therefore, my friends, if this is f, this is f dash. E to the power x into fx plus f dash x is e to the power x into fx plus c. Plus c. Yes, my friends. This is the third example. One more example. The friend will change its form. Change its form. I do here. Yes, friends, this is integral sin t no, it is sin log x plus cos log x with respect to x. Integrate this. Sin log x plus cos log x to x. See, you can't integrate it. Why? If it is sin x, you can integrate, but it is sin log x. We can't. Why? If it is sin f, you need what? 1 by f. Means f dash. What is the derivative of log x? 1 by x. That 1 by x is not there. Then, in this case, we must go with a substitution of what? Put log x equal to t. Log x is t. My friend, what is the base is e. When the base is not written, it is e. Apply the definition of log. Therefore, this number x equal to base to the power RHS. Number equal to definition of logarithm. Number equal to e base to the power RHS. X equal to e to the power t. Differentiating to get what? Derivative of x is dx equal to e to the power t into dt. Substitute now. Therefore, given integral is it is sin t plus cos t. What is dx, my friend? It is e to the power t dt. Rewrite it. It is integral. Your friend is here outside. It is sin t What is the derivative of sin t? Cos t. Cos t. So if it is f, it must be f dash. But if cos is f, what is the derivative of cos? Minus sin. Therefore, cos is not f, sin is f, because the derivative of sin is plus cos. It is what, my friends, now e to the power t f plus f dash is what? E to the power t into f sin t plus c. Put the value of t. E to the power t. E to the power t is x into sin log x. T is log x. T is log x plus c, my friends. This is also a good example under what? 2 mark question. It is also there in your textbook. I think it is a solved example. Maybe I not checked it. Not checked it. Like this, they may give this example also. Integral tan log x plus sec square log x dx. Again, same method. Log x is this. What is dx then? E to the power t dt. Then it becomes e to the power t dt tan t plus sec square t. What is the derivative of tan? Sec square. Then what is your f? Tan. Therefore, what is the answer? X tan log x. X tan log x. Remember, my friends, just to do this. Try yourself. These are some examples based on what? E to the power x, fx plus f dash x. Already 1 mark questions on this formula, e to the power x into fx plus f dash x. I have done while doing 1 mark questions. But what about these 3 or 4 examples? These examples will come under 2 mark questions, my friends. 2 mark questions. Then here and there, another 2 or 3 examples on integration, my friends. Just samples may ask under 2 mark. Just I will remind. After that, I will jump to differential equations under 2 mark questions. Under 2 mark questions, especially this year, 2021, with a reduced syllabus, the examiner strictly they wanted to give examples under in finding the order and degree of a differential equation. Very simple examples, my friends. I do that lot. Very simple example under 2 mark questions. 2 mark questions. Yes, my friends. First, I will complete another 2 or 3 examples on integration. After that, I will start with differential equations, my friends. Yes. See, copy it. Friends, I have selected next little bit either 2 or 3 mark questions. It is sin x upon sin x plus a. Sin x upon sin x plus a. In this case, my friend, in this case, you wanted this x must be converted in terms of what? Denominator first. You wanted the denominator, right denominator. To get numerator, what is the adjustment? Minus a. X plus a minus a is x itself. This x plus a is a special as the angle is there in the denominator. Then what is your observation? Sin of, if you take this as a, this is minus b. Sin of a minus b, which is sin a cos b minus cos a sin b. It is a theorem. Sin a minus b sin a cos b minus cos a sin b, this upon this. Rest is simplification. Sin x plus a into cos a upon sin x plus a minus this minus cos x plus a into sin x upon sin x plus a. And this sin x plus a cancels with sin x plus a. You are left with cos a. What is that? Cos a being a constant. That constant can be taken integral outside integral sign. When cos is taken outside, you are left 1 in the inside minus. This is a constant sin A outside integral sign. What is cos by sin? Cot. Cot x plus A. Now cos A into integral of 1 is x minus sin A into minus sin A into minus sin A. Cot, what is the integral of cot? Log sin x plus A plus C plus C. I hope understood. Sin x upon sin x plus A. You wanted denominator here. What is this? Sin x plus A, but you have only x minus A upon what? Sin x plus A. Sin x plus A. Sin A minus B theorem. This, my friend. This upon sin x plus A. Right. Simplify this upon denominator minus second term divided by denominator. Cancellation leaves cos A being a constant. Push it outside integral sign. If you push this outside, inside remains 1 minus sin A being a constant outside. Cos by sin is cot x plus A. Now it is integral of 1 is x minus sin A into integral of cot is log sin x plus A. Otherwise, you can use here itself f dash upon f. What is the derivative of sin? Cos. Then it becomes what? F dash upon f. What is f dash upon f? Log f. Or you convert in terms of cot and write the integral of cot is log sin x plus A plus C. Hope understood, my friends. Next is this. E to the power 2x minus 1 upon e to the power 2x plus 1. Multiply both numerator and denominator by what? E to the power minus x minus x. Minus x plus 2x is plus x. E to the power minus x into 1 is e to the power minus x. Again multiplication. Minus x plus 2x e to the power x plus 1 into e to the power minus x. If this is your f, e to the power x plus e to the power minus x, t, differentiation dt e to the power x plus e to the power minus x other than x, right? It's a derivative. Derivative of power is minus 1 plus with minus it becomes what, my friends? Minus, which is nothing but e to the power x minus e to the power minus x dx. Here, e to the power x minus e to the power x minus x dx. Then it is nothing but your dt. Therefore, given integral is 1 upon t into dt. 1 upon t is what? Log. Put the value of t log e to the power x plus e to the power minus x plus c. This is second example. It is also under 2-mark question, my friend. Good example. Good example. This is the third example, my friends. Third example. It has appeared in March 2017. Evaluate integral tan to the power 4 root x sec square root x upon root x dx. They are all connected. Derivative of tan is sec square. Yes. What is this? This is, my friend, independent tan to the power 4 root x. What is this, my friend? It is nothing but its derivative. See, this is written tan to the power 4 tan root x to the power 4. Power 4. This is your f, my friend. This is your fx. It is fx to the power n. This formula, my friend. Integral fx to the power n into f dash x dx. General formula is it is nothing but fx to the power n plus 1 upon n plus 1 plus c plus c. Yes, my friend, plus c plus c. See, what is your fx? Tan. Your fx is tan. Then you have to write f dash. This derivative is nothing but inside the bracket. What is the inside the bracket? Tan root x. What is the derivative of tan? Sec square root x. Is it x? No. Other than x. You want its derivative side. Derivative of root x is 1 by 2 root x. But you have only root x, my friend. This 2 is not there. That 2 is adjusted outside. I will explain once again. Tan to the power 4 root x is written as tan root x to the power 4. This is your f. Derivative inside. Derivative of tan. Sec square root x. It is not x other than x. You need its derivative here. What is the derivative of root x? 1 by 2 root x. But 1 by root x is there. 2 is not there. That 2 is adjusted here. Now it becomes what? Fx to the power 4 into f dash x. Fx to the power 4 into f dash x. By this formula, it is fx to the power 4 plus 1 upon 4 plus 1 plus c. What is 4 plus 1? 5 upon 5 plus c. 2 by 5. This, my friend. Tan to the power 5 is tan to the power 5 root x plus c. This is example which is appeared in your question paper, my friends. Question paper. Yes, my friends. These are some examples. Again, I have selected for what? 2 mark questions here and there. 1 or 2 steps may be more, but if not under 2, they will appear under 3 mark questions. But these 2 strictly 2 mark questions, my friend. Simple examples. Simple. Yes, with this, my friends, I can say what? These are some selected examples on integration under 2 mark question. 2 mark question. To the point of exam. In integration, my friends, I have given the distribution. What is it? Under 1 mark, 1 example. Under 2 mark, 2 examples. Under 3 mark, 3 examples. Under 5 mark, 1 example. Under 6 marks, 1 example. Totally around 8 examples. The number of marks is, I think it comes nearly 25 marks on integration. Other than application of integrations. What is the applications? There are 2 applications. One is area, not included. In area, you have 1 example under 3 mark question, 1 example under 5 mark, 8 marks. And differential equation, no 1 mark. 2 mark, 1. 3 mark, 1. 5 mark, 1. Totally 10 marks you can get in differential equations. In that, I do only 1 example under 2 mark question. The set contains under 2 mark questions. Now, this finishes integration, my friends. Finishes integration. Prepare it. I have done very neatly, nicely collecting examples from the model question papers, or question papers, everything collected. And even while doing, I have arranged the examples, type wise, group wise, and I have done it. 1 mark, 2 mark. And in between 1 mark, 2 mark. These are what? Either 2 mark, otherwise 3 mark questions. So, like that, my friends, you see, you can see the beauty of arrangement, beauty of these examples. But more detail, more examples like this, my friends. I have done 1 sample here. If you wanted like this, more examples, please refer my videos, Belagali's tutorial classes in YouTube. You can get in detail, my friends. I have done 3-4 examples on this. I have done. Yes, my friends. And next I do differential equations. There it comes. Order and degree. Very important is order and degree. And examples, especially this 2021. You may have 1 example on order and degree, which is a very simple concept, my friends. Now I do it. Yes. Okay, my friend. Differential equations. Now this completes integration. My friends, as I said, I do only 2 mark questions. 2 mark questions on differential equations. Differential equations. Only 2 mark. Not 3 mark and 5 mark. On differential equation, you have, my friends, 2 mark 1 example, 3 mark 1 example, 5 mark 1 example. Totally 3 questions, 1, 2, 3. 3 questions and 10 marks. 2 plus 3, 5 plus 5, 10. So, in differential equation, you have 3 questions with 10 marks. Remember, my friends, in this I have selected only 2 mark. If you wanted 3 mark, 5 mark, everything, I have done this chapter differential equations in my main videos. Main videos means what? The portion done for board exam, annual exam, board exam. I have done in detail differential equation. Everything in detail, my friends. Refer those videos. Available in Belagali's tutorials, tutorial classes. Yes, little bit you have seen a little bit what the basics. First I will explain. This 2 mark question, my friends. You have examples under find the order and degree of a differential equation. Find the order and degree of a differential equation. Order and degree, my friends. Order and degree of a differential equation. Order and degree. Degree of differential equation. I write simply DE, differential equation. To understand better about what order and degree of differential equation, we must first understand order and degree of a derivative. Order and degree of a derivative. 3 stars here, my friends. In the symbol, dny by dxn. In the symbol, dny by dxn. N denotes this n, my friend. This n denotes the order of the derivative. N denotes the order of the derivative. In the symbol, dy by dx to the power n. In the symbol, dy by dx to the power n. This n denotes this power of dy by dx. This power denotes, n denotes the degree of the derivative. In this symbol, n, it is a power, denotes what? Degree. In this symbol, this is dny by dxn. This n denotes the order of the derivative. Degree of the derivative. Then here itself, my friends, therefore, one is order, another is degree, means they are not equal. Dny by dxn is not equal to dy by dx to the power n. Yes. My friends, if what? Its order is n, can you tell what is its degree? If this is order, what is the degree? Degree is always the power of the derivative. What is the power of this derivative? What is this derivative? It is a derivative of nth order. It is an nth order derivative. What is the power of this bracket? Power of this bracket is 1. Therefore, for this derivative, its order is 1, its order is n, its degree is 1. In this symbol, my friends, power is degree. Then what is this? Dy by dx. What is dy by dx? It is a derivative of first order here 1. dny by dx 1 means order is 1, degree is n. Order is n, degree is 1. Order n, power of this derivative is degree, and this is order, this is power, degree. You must know this, my friends. It is a very, very important rule. Very important rule. Yes, my friends. An equation, now I will just go with what first. What do you mean by differential equation? An equation which contains an independent variable, and the derivative of dependent variable with respect to an independent variable of what? Various order and degree. Various order and degree is called a differential equation. It is called a differential equation. In particular, an equation containing the derivative of dependent variable with respect to one independent variable that differential equation is called as ordinary differential equation, my friends. Ordinary means what? It contains only derivatives with respect to single independent variable. It is what? It is a derivative of dependent variable with respect to one means single independent variable. Such a differential equation is said to be ordinary differential equation. Ordinary. These are two examples: xy into dy by dx2 plus x into dy by dx the whole square minus y into dy by dx equal to 0. This is one. Y is the equation which contains independent variable, dependent variable, and it is a derivative of dependent variable with respect to x. It is a second order. This is first order, power is given dy by dx. So an equation which contains independent, dependent, derivative of dependent with respect to x. Such an equation is known as differential equation. Here, y double dash, second, another notation, y double dash, it denotes second derivative of y with respect to x. Y dash, it denotes what? Derivative of y with respect to x. So dy by dx, this is d2y by dx2 plus sin y equal to 0. This is what? Another differential equation. 1. Next comes, my friends, the order of the differential equation. The order of the differential equation is the order of the highest derivative. The order of the differential equation is order of the highest derivative occurred in the differential equation. Then what is the order of the differential equation? Order of the differential equation is nothing but order of the highest order derivative. Order of differential equation is same as order of the highest order derivative. Highest order derivative occurring in the differential equation. Yes, my friends, you take this here. Here it contains, it is a derivative of order 2, it is a derivative of order 1, which is highest order. Highest order derivative is this, my friend. Then your order of the differential equation is same as order of this derivative. What is the order of this derivative? 2. Then what is the order of this differential equation? Is 2. It is highest order of the derivative. In this case, my friends, it is also what? Second means 2. Here also its order is 2. What about here? Its order is also 2. Correct? Next, read, my friend. Next. This is the degree of the differential equation. This is another very important. The degree of the differential equation is the highest positive power. This power must be positive. N must be positive. Positive n. Highest positive power of highest order derivative. Appear in the differential equation after it is made free. From radical signs. Radical signs means square root, cube root, like this. Radicals and fractional power. This n should not be fraction. 1 by 2, 3 by 2, cube root, no. While writing the degree of a differential equation, this is the highest power of highest order derivative. While writing that power must be free from, or differential equation must be free from radical signs, square roots, cube roots, and it must be free from fractional powers. There should not be 1 by 2, 2 by 3 like that. No. The differential equation must be free from square root, cube roots, free from fractional powers, and the power must be positive. Positive should not be negative. Power must be positive. One more is there, my friend. One more is there. This. The differential equation must be a polynomial equation. It must be a polynomial equation in derivatives. Like this. It must be polynomial equation. This is a polynomials. You know what I mean by polynomial? It is 5x squared plus 10x plus, like this you can write. It is x squared plus 5x plus 6. What is this? It is a polynomial. If you say this equal to 0, this becomes polynomial equation. Means this x is repeated here. X square is there, x is there here. It is x to the power 0. X to the power 0 is 1. See, decreasing x square, x, like this. X to the power 0 means this differential equation must be a polynomial in derivatives. Polynomial in derivatives. Yes, it is a polynomial in derivative. It is also what? A polynomial in derivative. This is sin y means what? Our constant 6, like that. 6. It must be polynomial. Down. The degree of the differential equation which contains the terms like sin divided by dx. My friends have written purposely. This is sin y. It is a dependent variable. But what is this? It is its derivative. Angle is its derivative. Sin divided by dx, cos divided by dx, e to the power divided by dx, tan d2i by dx to, like this man. Why? This sin x is a what? Sine series we can express in terms of what? Series. Therefore, my friend, if it is sin divided by dx, you can write it in the form of what? Sine series. Therefore, sine series means what? The degree is not defined. Degree is not defined. Therefore, my friends, the degree of the differential equation which contains the terms like sin divided by dx, e to the power y1 means what? Divided by dx, tan d2i by dx to cos y triple dash, like this. Cos y triple dash. Triple dash means what? It is a derivative. d3y by dx3, order 3. In that case, the degree of this differential equation is not defined. So, while writing the degree, we have to take much care. What is the degree? Power of a highest derivative. What kind of the power? Power must be positive. While writing that power, you must observe differential equation must be polynomial in x. It must be free from fractional powers. It must be free from radical signs, square roots like that. You must take maximum care in writing the degree. This is order and degree of the differential equation, my friends. I hope just 1 minute I give just to go through all these things. I do some examples based on this. Yes, friends. Now we do 1 or 2 sets of examples on order and degree of a differential equation. That comes under 2-mark question. Friends, I have written some differential equations, and we have to write what its order and degree. Find or determinant. Any one word they use, either find, otherwise determine. Order and degree, they are mentioned here if defined. If the degree is defined, you write the degree of the following differential equations. This is the first already discussed. xy into d2i by dx2 plus x into dy by dx minus y divided by dx equal to 0. Always order depends upon order of the highest derivative, my friends. This is your main person. Just mark it. What is its order? 2. What is its degree? Degree is 1. Degree is 1. Highest order derivative to mark in the differential equation. Highest order derivative. Its order of the derivative is order of the differential equation. Its power 1 will be the degree of the differential equation. This is second. d3y by dx3, d2y by dx2, dy by dx plus y. Order is derivative of order 3, order 2, order 1. No order, it is a dependent variable. Then which is your friend? This is your friend, my friend. Highest order. Highest order. What is its order is 3. What is the power of the bracket? Is 2. So order is 3, degree is 2. What I told? First you have to mark that highest order derivative first, my friends. Highest order derivative. Then you write its order. While writing the degree, you must see the differential equation must be free from sine dy by dx, cos d2y by dx2, e to the power dy by dx, tan sec. It should not be. If they are free from that, degree is defined. If it contains such terms, degree is undefined. Degree is undefined. For the second, order is 2, degree is 2. Order is 3, degree is 2. Next example, this my friend. dy by dx the whole square, dy by dx, sine square y it is. Angle is theta. Angle is not a derivative. Angle should not be not a derivative. It is not derivative. dy by dx, dy by dx. In this case, you have to consider the highest power of highest order. Anyway, highest order is 1. But what is the highest power? Highest power is 2. Then, highest power degree is 2. What is the order, my friend? 1. Next, ds by dt to the power 4. 3s into d2s by dt2 equal to 0. Here, second order, first order. Second order, first order. Then who is your friend? Second order. What is its order is 2. What is its power? Its power is 1. Its power is 1. Degree is 1. Highest order. Order is 2. Power is 1. Degree is 1. Degree is 1. This is next example, my friend. d2i by dx2 equal to cos 3x plus sin 3x. Yes. It contains only one this derivative term. It contains only one this derivative term. Tell my friends in this case, what is its order? Order is 2. Tell what is its power? Is 1. Its degree is 1. Next, d2i by dx2 to the power 3 plus dy by dx the power 2 sine dy by dx, my friend here. This sine angle is what? A derivative. In case of sine theta, theta should not be derivative. Theta must be ordinary number. But in this case what? In this case what? Sine of the derivative or trigonometric ratio or exponential function of the derivative. In that case, degree is not defined. Degree is not defined. What about the order? In among the three, highest order is 2, my friend. Highest order is 2. Don't write this power 3. Why? In the differential equation which contains the terms like sine dy by dx, cos dy by dx, e to the power dy by dx, such terms contains. In that case, degree is not defined. Next, d4y by dx4 plus cos d cube y by dx. Again what? Cos of the derivative. Cos of the derivative means what? First write that. Degree is undefined or not defined anything. Degree is undefined. Undefined. What about the order? This is the only one. In that case, what is the order of the derivative? 4. Order is 4. Next one, what is it? Y triple dash, y double dash, e to the power y dash. Y dash means first derivative, second derivative, third derivative. Then e to the power dy by dx. It tells what? Degree is undefined. Degree is undefined or not defined, anything, right? Not defined or undefined. Now what about the order, my friend? Order is, yes, highest is 3. 3 dash. Here. Now it is free from any trigonometric ratio of derivatives is free. Now both order and degree are defined. Which is the highest order? 3, 2, 1. This is the highest order. Then its order is, my friend, 3. What about the degree? Degree is 2. Its power, degree is 2. Order is 3, degree is 2. This is how we have to find order and degree of a differential equation. If you write order correctly, you get 1 mark. Degree correctly, you get another 1. These are 2 mark questions. 2 mark questions. I write few more examples, my friends. Write it. Write it. My friends, I have done examples on order and degree. Some examples I have written, just you do it yourselves, DIY, do it yourselves. In this, my friends, your friend is Y dash. Y dash means what is the order? Order is 1. What is its degree? Degree is also 1, power of this. In this, my friend, in this, Y double dash. Y double dash means order is 2. What is the power? Degree is 1. Degree is 1. Degree is 1. In the next, my friends, this d3y by dx3 plus 2 into d2y by dx2 plus dy by dx is here. Highest order is 3, my friend. What is the order 3? What is its power? 1, right? 3 and 1. Next, d2s upon dt2 to the power 4 plus 3s into d2s upon dt2. Both are same order. Same order. When the order is same, you have to take the highest power. Here, what is the power of this? Power of this is 1. Among the two, which is the highest? 4. Then, degree is 2, order is 2, degree is 4. So, in this case, order is 2 and degree is 4. In this, my friends, dy by dx, dy by dx. It doesn't contain any sign of derivative. No. Then both order and degree defined. What is the order? In this case, order is same. Dy by dx, dy by dx. Then the order is 1. Order is 1. What is the highest power? 3 is there, 2 is there. So the highest power is 3. Degree is 3. This, my friend, tan of derivative means what? Degree is not defined. Degree is not defined. And what about the order? Highest order. Order is 2. Order is 2. Order is 2. Don't write its power because tan of the derivative means what? Order. Degree is not defined. Order is 2. These 1 mark, 2 mark questions. Then there is one example in your book, my friend. One example in your book, which depends upon this result. This result I have written as a note. What is that note? The order of the differential equation. Order of the differential equation is same as the number of arbitrary constants. Number of arbitrary constants in the general solution of the differential equation. In its means what? In its means in the general solution of the differential equation. What do you mean by this, my friend? Number of arbitrary constants equal to number of arbitrary constants equal to order of the differential equation. Therefore, number of arbitrary constants equal to order of the differential equation. Order of the differential equation. This is one example that will also come under 2 mark question. Find the number of arbitrary constants in the general solution. Of differential equation of 4th order. Yes. What is it? Number of arbitrary constants equal to order of the derivative. What is the order? 4. Therefore, number of arbitrary constants in the general solution of the differential equation of 4th order is what? Order of the differential equation. What is the order of the differential equation? Is 4. Then another is, my friend, particular solution. This is a particular solution. General solution is what? General solution is a solution which contains a number of arbitrary constants equal to order of the differential equation. What is general solution? General solution of a differential equation is a solution which contains number of arbitrary constants equal to order of the differential equation. That number of arbitrary constants and order of the differential equation is same. If a solution contains arbitrary constants which equal to order, in that case, that solution is said to be general solution. Then what is particular solution? Particular solution of a differential equation is a solution obtained from general solution. Giving a particular values to the arbitrary constants. From this, what is clear? Particular solution is a solution which is free from arbitrary constants. There is no arbitrary constants. Then number of arbitrary constants in the particular solution is 0. Why? No arbitrary constants. That is the second part. Find the number of arbitrary constants in the particular solution of the differential equation of order 3. Yes. Number of arbitrary here. Particular solution is a solution free from arbitrary constants. Therefore, number of arbitrary constants in the particular solution is 0. General equal to order of the differential equation. Particular solution, no arbitrary constants. So the number is 0. My friends, these I have considered what? Some examples on differential equation of under 2 mark questions. Find degree and order and degree. Actually, another alternative for 2 mark is, normally they used to go with what? Formation of a differential equation. That formation we have done where in the general solution. That too, the beginning examples what I have done. Those beginning examples are good examples under 2 mark questions in formation. But reduced syllabus, that formation is not there. As the formation is not there, normally especially this 2021 for your exam, you have under 2 mark questions differential equations, order and degree. Otherwise, formation of a differential equation. Yes, my friends. With this saying, what I have completed 1 mark and 2 mark questions integration. Application means only differential equation under 2 mark question. There is no 1 mark, 2 mark questions. But 1 mark they may ask only one part like this. Only this part. Number of arbitrary constants in the general solution of differential equation of order 4. If you write 4, you get 1 mark. 1 mark only that first part. Second, this is what? Another 1 mark like that. Yes, my friends. Now, you know better now everything, which is 1 mark, which is 2 mark, everything you know now. So, with this, I can say What, my friends? Integration differential equations. 1 mark and 2 mark examples completed. Next, I will start with factors, matrices and determinants, relations, functions, like that, my friends. I do few more chapters. 1 mark, 2 mark questions. Only 1 mark, 2 mark. Not 3 and higher. No. Only part A and part B, my friends. Part A, part B. No part C, no part D, no part E, my friends. Yes. Saying this. With this, we will say what? Today it is enough. My friends, saying a lot of thanks to you. Namaste, my friends. Namaskara. Namaste. Good day, my friends. Good day.